Hi, everyone. Welcome to Stoichiometry lecture. This is the second part of Chapter 3, and this will wrap up Chapter 3 for you and hopefully help you with the remaining problems in Chapter 3 problem set. So what is stoichiometry? It is the relationship between relative quantities of substance that take part in a chemical reaction. So just abbreviated, I would say that it is the mass mole relationships in a chemical reaction. So when you show your balanced equations, such as this one here, 2H2 plus O2 goes to 2H2O, the coefficients that are out in front of the hydrogen, the oxygen, and the water give us the mole ratio between each of the components. So as an example, so what is the mole ratio between hydrogen and water in this balanced equation? It's a 2-to-2 ratio or a 1-to-1 ratio. So what that means is that for every 2 moles of H2 molecules, I will produce 2 moles of H2O molecules. So again, back to last week when we talked about the mole, it's just a counting unit. It's a quantity used in chemistry for very small things, such as atoms, molecules. So then let's look at what is the ratio between hydrogen and oxygen. The ratio between hydrogen and oxygen is a 2-to-1 ratio. For every 2 moles of hydrogen, I will need 1 mole of oxygen O2 in order for the reaction to proceed. And then we can also look at the ratio between oxygen and water, and that's going to be a 1-to-2 ratio. So as an example here, let's say I have 2 moles of hydrogen, then it means that 1 mole of oxygen is required to make 2 moles of water. That's what the balanced equation tells us. So the mole ratio is always constant, and it depends on the coefficients in the balanced equation. So given this reaction from above, it's a pretty simple one. I figured it'd be best to start out with a simple one. If 3 moles of H2 reacts with excess oxygen, and I always say excess is you're guaranteed an easy problem in stoichiometry if there's one of your reagents is in excess, and I'll explain that on the next segment. So if 3 moles of hydrogen reacts with excess oxygen, how many moles of H2O will be produced? So I'm just going to use my dimensional analysis and show the stoichiometric relationship. And so I start out with my 3 moles of hydrogen. If I have 3 moles of hydrogen, how much water will I get? Well, since it's a 2-to-2 ratio between water and hydrogen, it's going to end up being 3 moles of H2O. So I set it up. I know it's pretty straightforward and simple here, but it's really nice to use the dimensional analysis and see how it works to give you that final answer. Then another example would be how many moles of O2 are required to react with 5 moles of H2. So now I'm talking about my 2 reactants. So I can make any comparison, reactant to reactant, one reactant to the product, another reactant to the product. You can do any one of those relationships. So 5 moles of hydrogen, set it up so that the mole of hydrogen unit cancels and you're left with just the mole of oxygen unit, which is the answer you're looking for, because it says how many moles of O2 are required. So I'd set it up this way. The one that I know, the quantity that I know, the relationship from the balanced equation, and then I'm going to get my final answer. But note that moles of H2 would cancel out with moles of H2 to leave you with mole of O2. Okay, so now let's look at a different type of scenario with grams. same reaction. And so this problem says if 2 grams of H2 reacts with excess oxygen, then 2 grams of H2O will not be the product. So when you're in grams, things are a little bit different and you have to make further conversions. So we're going to use the dimensional analysis approach, and we're going to start out with the 2 grams of hydrogen, which is what the problem is based on. Okay, I need to convert the 2 grams to moles by using the molar mass of hydrogen, and I'm just going to use 2.02 grams for every mole as a conversion factor, and I'm just going to turn it upside down. I'm going to put 1 mole of hydrogen on the top is equivalent to 2.02 grams of hydrogen. Then I'm going to use the mole ratio from the balanced equation. That's a very important part here. It's a 2 moles of water to every 2 moles of hydrogen. And again, you can see units would start to cancel out here. Grams of hydrogen would cancel grams of hydrogen. Moles of hydrogen above the dividing line would cancel moles of hydrogen below. At this point in my problem, I would have moles of H2O. But now I just go one step further, and I can say the molar mass of H2O, which is 18.02, per 1 mole of H2O. Now I have it all set up so that the only unit that would be left would be the grams of H2O, which is what I'm trying to find. So if I now do my mathematics here, I'm going to take 2 grams, I'm going to divide by 2.02, I'm going to multiply by 2, then divide by 2, then multiply by 18.02, divide by 1. Clearly, you don't have to do those steps where you're multiplying by 1 here, dividing by 1 here. So if you forgot your mole ratio in this sample problem, it wouldn't make any difference because it's just a 1-to-1 ratio there. But I put it in so that you don't ever forget to put that ratio in, because if it's not a 1-to-1 ratio, then it'll be wrong, because you get that piece of your stoichiometry in your dimensional analysis. You get that piece from your balanced equation. So we'll go further. We'll try another one. How many grams of O2 are required to react with the 2 grams of H2? So I start out again, pretty much the same exact way I started the other one. 2 grams of H2, I'm going to convert it to moles because my grams above will cancel out with grams below. And then I'm going to use, I have it starred here to indicate its, huge level of importance here in your stoichiometry, the mole ratio. So now I want to look at oxygen compared to hydrogen. And according to the balanced equation, it's a 1-to-2 ratio. When there's no coefficient out in front of the molecule, it's assumed to be a 1. So now this is a 1-to-2 ratio. And then I'm going to use the molar mass of oxygen, 32 grams of O2 for every 1 mole of O2. And if you keep going, you'll see how your units continue to cancel out, and the only thing you would have left would be grams of O2. And so I would take 2 times 1, divide by 2.02, times 1, divide by 2, times 32, divide by 1, and I get 15.84. So you can see here that your mole ratio is definitely going to have an impact on your answer to the problem. Whereas here, the 1-to-1 ratio, you wouldn't have even noticed if you made that error. I'm going to stop right there for now.